Hi everyone, let's see one of the question on functional dependency. Find the following preserved or not for the given decomposition. Means here they have given a relation R with set of attributes are like this, and set of functional dependencies given, set of decomposed relations also given. They are asking for finally whether attribute is preserving or not, lossless is preserving or not, functional dependency is preserving or not. Okay, so let's try to do it. Right, let's take the first one, attribute is preserving or not. Guys, you know the meaning. Attribute is preserving or not means we have to take out the decomposed relations like R1 set of attributes, R2 set of attributes, R3 set of attributes, and so on, Rm set of attributes. Finally, you have to make them combine all these attributes. If it is equal to actual relation attributes, I can say that it is attribute preserving, right? So now with the given scenario, if I call this as a relation R1, R2, and this is the relation R3, what are the attributes possible for the relation R1? Are like SSN comma ename, good. And what are the relations for R2? P number, P location, P name, good. What are the relations for the R3? SSN, P number, and hours. Guys, in the previous videos we have seen them with a simple names like A, B, C, D, like that, right? But it's a kind of a real-time example where this example is related to the company database. If anybody have the idea about the company database, I have taken it from there, right? So R3 relation attributes are SSN, P number, hours, right? So if you try to write removing the duplicates, you will get SSN, ename anyway, and P number, P location, P name, P number, P location, P name, right? Yes. If you take the SSN is a duplicate one, yes, so P number is duplicate one, and finally you have to write the hours, right? So this is the set of attributes which are possible when you perform the union operation over the R1, R2, and R3. Now, is it equivalent to the actual relation? Try to check, right? SSN is there, ename is there, P number is there, P name is there, P location is there, hours and hours are. As all are satisfying, as all are available, I can say that first one is attribute preservative. Okay, fine. What about the second one? Like if you take the second one, that is lossless decomposition or not, or lossless join property is satisfying or not, you have to go with either of the case. Like one is intersection method is there, another one is tabular method is there. So as it may be error prone, the intersection method error prone, it will take very less time, right? Yes. So it's if you want to have the errorless solution, definitely you may go with the tabular method, which is a lengthy procedure. So in intersection method, I am trying to take out the two relations. So can we take any common thing from R1 R2? R1 and R2, anything is common? No. From R2 and R3, can I take anything as common? Yes, right? From R2 and R3, I can take P number as the common one. So what I can do now, before combining these two relations R2 and R3, I will try to find out the P number closure, right? The reason is, if I am trying to combine them, it should be a candidate key. Otherwise, it is going to generate various kind of spurious table, which is a kind of bad schema again, right? So I can able to find out the P number closure. P number closure is, if you are able to observe, this is what you are going to get. P number closure is, you are going to get anyway P number. From P number, you are going to get P name. From P name, you are going to get, it should be P name and P location. And any other things are possible? No, this is the only thing possible, right? So if you observe, this P number closure is going to determine the R2 itself. I can say that this P number is a candidate key here, right? As it is a candidate key, I can able to simply combine R2 and R3. So R2 is P number, P location, P name, P name, SSN, P number and hours. So this is the combination for R2 and R3. Why I have combined? As P number is a candidate key, I have combined. Now you have to check it with R1, right? In R1 SSN is there. Is that SSN is common, right? SSN is common in R1 as well as in the resultant relation of R2 and R3. Now if you would like to combine, you need to check whether SSN is a candidate key or not. If you are going to find out the SSN closure, you will get anyway SSN. From SSN you are going to get ename guys from this FD. So I can say that as it is deriving R1, I can say that SSN is a kind of a candidate key. If SSN is a kind of a candidate key, so now finally I am going to combine these two, right? Means R1, R2 and R3 you are going to get all the attributes. So I can say that it is lossless decomposition only. Lossless decomposition only, right? So next one, check with whether it is FD preserving or not, right? FD preserving means you have to find out the set of functional dependencies possible for the relation R1, I can call it as F1. Set of functional dependencies possible for the relation R2, I can call it as F2, and so on. Set of functional dependencies possible for the functional set of functional dependencies possible for the relation Rm, I can call it as Fm. Finally you need to make them union, and if you are able to find out its closure when it is not possible, that should be equivalent to the actual functional dependency closure. Then I can say that FD preserving, right? Guys, to get more clarity, you can go with the previous videos. It's better, right? So here I am just assuming that you know all the concepts, so I am trying to solve the solution here. Okay, so guys, find out. So first take the relation. One relation is SSN comma ename. SSN comma ename. Right? Check whether it is having any kind of FD is possible or not. Right? So if you find out SSN closure, you are going to get SSN comma ename. Good. From ename anything is there? From SSN anything is there? No. So I can say that SSN is going to determine ename is one kind of functional dependency is possible. Similarly, try to find out ename closure. Anything is possible? No. It is going to generate only ename, which is a trivial one. So I should not consider. Similarly, if you take two level kind of attributes, they are not going to be considered because it is equivalent to the actual relation degree. So I should not consider. And take out the another relation. Another relation is P number, P location and P name. Right, guys, try to find out the FD is possible or not here. So the FDs are maybe possible with a single attribute P number closure. If you try to find out the P number closure, you are going to get anyway P number, you are going to get P location, you are going to get P name also, right? So this is the FD, it is possible. So I can say that from P number I can get P location, along with that P name you are going to get. Good, right? Next, similarly find out the P location closure. Is there any FD is possible? No, only trivial is possibility. Similarly, P name closure, is there any FDs are possible? No, only trivial is possibility. So I can say that I can cancel. Similarly, you have to go with two level attributes, right? Two level attributes means P number comma P location closure. If you are able to find out, it is going to generate P name, right? So simply I can say that P number comma P location can determine P name. So this is one of the FD possible for us. FD possible, right? Similarly, take out with the P number and P name, another possibility of two level attributes, right? If you are going to find out this one, you will get because the reason is P number itself is going to determine the remaining two. You can get the if you are going to add this also, you are going to get the other one, right? So that's the reason I am trying to write directly. So P number comma P name derives P location. So this is one more kind of FD possible. Similarly, try to take out with another kind of possibility, that is p location comma p name. Guys, now try to check whether any FD is possible with this one. No, it is a trivial, because p location or p number cannot able to determine any other things, right? So any other things are there. So I did with these two and these two, so all possibilities are done, right? Next, if you are going to take 3 level attributes, p number, p location and p name, if you try to find out the closure, you are going to get those 3 only. Even if you are going to get any other things, those are not in our relation, I can simply skip this one, right? Yes. So we did with the second relation, right? Next, try to take the third relation. Third relation is SSN, p number and hours, guys, right? So if you are able to find the set of FDs possible here, so SSN closure is SSN anyway. From SSN you are going to get ename, guys. From SSN you are going to get ename, and any other things are there? No. But if you are able to observe, SSN is a trivial, ename is not in our relation, so SSN is not possibility. Similarly, if you are able to find out p number closure, you are going to get p number, I am writing shortcut, you are going to get p name, you are going to get p location, and any other things are there? No. So p number can able to determine, what are the things that possibilities are p number, and p name and p location anywhere not there in our relation, so it is again a kind of trivial only, okay, fine. Next, try to check out with hours closure, right? Hours closure anyway is not in our FDs, any one of the FDs left hand side, so I can able to simply skip this one. Next, try to do it with the combination. If you do it with the combination SSN comma p number closure, you are going to get SSN p number anyway. From SSN you are going to get ename. You are going to see, I am trying to write SSN p number. From SSN you are going to get ename. From p number you are going to get p name and p location. They are not in our relation. Ename is also not in our relation. But if you observe, SSN p number can able to determine the combination as hours. So I can write as SSN p number can able to determine hours, guys, right? So I mean I try to do it with the two level. Next, try to do it with SSN and hours. You are not going to get anything, so which is not a kind of FD possibility. Similarly, try to do it with p number and hours, so you are not going to get any kind of new FDs, right? Next, we'll go with 3 level. If you go with the 3 level, it is going to get again the same kind of trivial functional dependency possible. If at all, if it is going to get anything, they are out of relation, so I cannot able to write 3 level attributes also, right? So finally, this is the FD possible in this particular relation, right? Now at the final step, you have to check whether actual FDs is preserving or not, right? So try to take out SSN determines ename. Is SSN determines ename? Yes, it is possibility. Yes, it is done. Similarly, try to check is p number determines p name comma p location, right? Is p number determines p name comma p location? Yes, it is satisfied. So this is also preserved. Next, SSN p number derives hours, right? If you are able to observe, this one is available at this particular location, right? Means this is also satisfied. As all the FDs are preserved in the sub-decomposed relations, I can say that FD is preserved, right? In this particular example, all 3 kind of properties are satisfied, or 3 properties are preserved, right? And these are some of the additional functional dependencies which you understood it directly, right? Fine. So this is the way you can able to define or solve whether a particular thing is preserved or not. I hope understood clearly. Thank you.